Hello everyone. Today we are going to be learning about a chemical solution called a buffer solution. What is a buffer solution, you may say? Well, a buffer solution is a solution that is made up of a weak acid or base and its conjugate base or acid, depending on what you use. So for example, a buffer solution may contain the weak acid acetic acid. So it also must have its conjugate base, which is acetate, for it to be known as a buffer solution. So the reason why we have buffers is because it limits the amount of pH change within a solution when a strong acid or base is added to it. And why this happens all comes back to Le Chatelier's principle. This is due to the fact that when you add a strong acid or base to the buffer solution, you are disrupting the equilibrium. So to account for this, Le Chatelier's principle discusses about how the equilibrium shifts left or right depending on what is being added and what type of buffer solution you have. And this is done to re-establish equilibrium within the reaction. So when you add a strong acid to a buffer solution containing a weak acid and its conjugate base, as shown, the equilibrium will shift to the left. This happens because when you add the acid, you are basically adding more hydrogen or hydronium ions to the reaction, meaning there is more products than reactants. So to compensate for these additional ions, the equilibrium shifts to the left to create more reactants due to increase in products and therefore re-establishing equilibrium. Though when you add a base to the same buffer solution, it will instead shift the equilibrium to the right. This is due to the fact that the hydrogen ions react with the hydroxide ions from the base, meaning there is a decrease in hydrogen or hydronium ions, and therefore directly correlating to a decrease in products for the reaction to take place. So to compensate for this reduction, the equilibrium shifts to the right so there can be more products formed. This movement then re-establishes equilibrium in the reaction. Then when you have a buffer solution containing a weak base and its conjugate acid, and a strong acid is added to it, the equilibrium will shift to the right. This occurs due to an increase in hydronium ions on the reactant side, because of the acid being added to it. Therefore meaning more products are created as the equilibrium has to shift to the right to re-establish equilibrium. Where then if you add a strong base to this solution, it will just be the opposite, as the equilibrium will shift to the left, because of the hydronium ions reacting with the base being added, meaning is reducing in the reaction, so the equilibrium must shift to the left to account and to create more reactants then. So now you may be thinking, why can't a strong acid or a base be used in a buffer? Well, they can't be used in a buffer system because they completely ionize, meaning there is nothing left in the solution that can act as a buffer when acids or bases are added. This means that the pH won't stay around the same, instead it will drastically change, whereas weak acids and bases don't completely ionize, meaning there are still things left so that they can act as a buffer system. Something that also comes in handy is determining the pH of the buffer solution that is created. So for some questions, you may be given the one above with known values. Now the first thing you have to do is find the number of moles for both the acid and its conjugate base. This can be done in many ways, but depends on the values you're given and what formulas you will use. So once completed like this, you are then to multiply the Ka value by the acid over its conjugate base. Once this is done, you now have the concentration, so all you have to do is use the formula. pH equals negative log of the concentration to get your answer. This can be repeated and altered for many of the questions you do. And in some of the questions you may have to use ice tables or even dilutions to get some of the answers that are required. So I hope this helped you guys effectively learn about buffers today. Thank you.